Hello. Hello, everyone. Uh, my name is Stefan. Unfortunately, I'm not a professor. I'm from the company side. But still, I'm very happy and honored to be invited to present a presentation which is about GNSS technology, the development, the industry, and the applications. So I want to make sure that everyone can hear me, right?
Yes, clearly.
Okay, good.
Yes.
I'm gonna start to share my screen. Okay, here we go. Okay, once again, I want to make sure that I have already successfully shared my screen, right?
Yes.
Yes.
Okay, good. So I will go into today's presentation. My name is Stefan Wei. I am the general manager of marketing center in High Target Company. So I have been studying and work in the GNSS industry for more than 12 years. Today, my topic is satellite navigation technology and industry applications. But I say that before I do this presentation, I have go through the name list of the attendees online. But I found that you are from many countries and many regions, and your background are different. Like some of your background are remote sensing, computer, even chemical and other majors. So go back to my presentation today. I will more focus on the high precision applications. So here's the content of my presentation today here. I will talk about 4 parts: development of satellite navigation technology, second, overview of GNSS market, and 3, high precision GNSS industry applications, and 4, a little bit about high target. First of all, when we talk about the satellite navigation system or technology, and many of us, we may think about GPS. 10 years ago or 12 years ago, when I first start to work, everybody's saying that GPS is the satellite navigation system, which means the satellite navigation system equal to GPS. But if we take a look at the history, we will find that the GPS was the first system which was launched in the 1978, and it started to be operational for the whole world. The year is 1993. So because it is the first system to provide navigation, positioning, and timing services globally, so we say GPS was equal to a navigation system. But nowadays, when we talk about GNSS, it means Global Navigation Satellite System. It is a general term describing any satellite or constellation that provides positioning, navigation, and timing services on a global or regional basis. So here's a very important part, that is neither global system or a regional system, they all can be told as a GNSS system. Because GPS was the first system which was launched in 1978, but after that, a lot of systems was launched. So here shows a global and regional system that many have on the Earth. So left part global, because we know that GPS is from the United States, the Beidou or BDS is from China. And there is another system, GLONASS from Russia. And of course, Galileo system from European Union. Those systems are global wide. Many people may be very familiar with that, but I want to tell a little bit more about the Beidou GPS or Beidou BDS. Beidou system was first be operational in 2011, but at that time the services only covered the Asia Pacific area. But until 2020, the BDS system covered all the world. We call it BD3. So since that time, the Beidou BDS is the worldwide operational system and already have been used by the whole human beings on the earth. And also let's take a look at the regional system. Like Japan, they built their own regional system to improve the accuracy for the area which is near Japan area. It is called QZSS. And also the India, they built their own system, IRNSS. And we believe that if we take a look at the plan, because the plan is open or public to the society, and you can check that a lot of countries still put in the efforts to building more satellite systems globally or regionally. Until now, we can tell there are more than 120 satellites, navigation satellites is flying around the Earth. And the frequency is more than 10. How we can benefit from the numbers of the satellites? I can tell you some examples when that time was 2011. At that time, still we are using a GPS single frequency receiver. It is 20 channels, only receiving the GPS signals, but the accuracy is very low, like 3 or 5 meters. Even you the recorded static data to do the post-processing, the accuracies, of course, can be improved. But because the satellites and the frequencies are very limited, the data is very limited. It's very less data. But until now, after 12 years or 10 years development, there are 120 satellites, navigation satellite on flying around the Earth, which means if you take out the phone, a single frequency phone, it can still track more than 20 or 25 satellites, right? So I think many people know that 4 satellites, then if you track 4 satellites, then you will have your position, right? And more satellites is more stable, higher accuracy, and the coverage time is less. So that's the benefit that we have brought to the society. And as a company, we, of course, when we build any GNSS receivers or equipment, well, we are trying to catch the steps and following the worldwide systems to ensure all the satellite and frequencies we can track. And since the accuracy for the global system was around 3 to 5 meters, so many countries or regions they started to build a satellite-based augmentation system, which is called SBAS. You can see from this map, SBAS including the WAS, IGNOS, SDCM, BDS, SBAS, MASAS, and GAGAN. And still, I believe the system is building continuously. the main purpose to build a S-Bus is to improve the accuracy, because like for the forestry, for the agricultural, it requires for the less than 1 meter accuracy, but using the just GPS signal or Beidou signal, single frequencies, single positioning, you can never receive that good. So S-Bus comes. But after that, here's about correction services. In order to improve the accuracy more, like down to the centimeter level, the companies or scientists, they build another technology, which is called RTK, real-time kinematic. In this mode, we build a base station or base station network to receiving satellite signals and broadcasting the correction services. Then a person who carry a rover is like equipment to measure or to tracking or to move. The rover received the correction from the base. Then in that case, the accuracy have been improved down to 1 centimeter. That is a huge approach to for the GNSS positioning technology. But still, RTK have a limitation because, as I told, that it requires for the communication, rather using the radio communication or using the telecom communication. So every communication have a limitation, right? Like in the desert, in the ocean, we cannot build a base station in the ocean, right? So RTK have the limitation, but it do solve a lot of problems. And then the technology goes to PPP, precise point positioning, which is using a communication satellite to transforming or broadcasting the PPP services to the rovers or to the devices. The purpose is to break up the gap for the communication, because a communication satellite is on the Earth. It's very far from the Earth. So the coverage of the communication satellites is huge. Especially can cover the ocean, the deserts, and some very special or limited areas or regions. But still, PPP have limitation. The limitation is the time. The time, it requires for more time. Like you put a receiver using the PPP technology, it takes at least 10 to 15 minutes to coverage. So the application for the PPP have also limitations. But we also think about to combine RTK technology with the PPP. Then we have the PPP RTK. PPP RTK is a precise point positioning system, which is combine the RTK real-time reference station network, which is on the base, on the Earth. So PPP technology have improved so much performance for the positioning. Like the coverage have been expanded. The accuracy can still achieve similar as RTK. And also the convergence time is less than 1 minute, which is similar as RTK. So based on PPP RTK, we can do a lot of applications. For the second part, I want to share a little bit data sheet about the GNSS market, because understanding the market growth or development is the key to develop or adapt your technology to the industry? First of all, let's take a look at the global market. When we talk about the global market, we say that in the global world, there's a report from the EU SPA, and it's saying that in 2021, the global GNSS market, the revenues is about 235 billion US dollars. And they also predict in the 2031, the total market could be reached to 582 billion US dollars. The CAGR is continuously around 9.5%. So this 9.5%, it's not, if we don't know the GDP, I want to give one example about the GDP growth. I don't know whether any of you guys know the average GDP growth for the whole world. Like in China, the GDP growth is about 6% per year, right? In the US, maybe 2 or 3% 1 year. In some other countries, maybe even less. The average GDP growth for the whole world is around 2% to 4%. But this CAGR is 9.5. That means our industry or GNSS industry development speed is much more higher than the GDP growth. Then, of course, I need to mention that the GNSS market, the market size, including the device revenues and the services revenues. So I want to also share a little bit about China market, because the China market is growing very fast, much more fast than the global wide. Here's also a chart about, which shows the GNSS market growth in the past 15 years, and it also predict the next 5 years. It shows that in 2025, the total China GNSS market will reach to 152 billion US dollars. And now, 2012 or 2021 is around 78 or 80, which means the CAGR is continuously remain as more than 20%. So 20% compared to 9%, that the speed is in China, the market growth speed is much more fast than the global world. But of course, including the high precision GNSS industry, and also including the like commercial use in your phone, in some tracking devices. Then let's keep going to the high precision GNSS market in China, because my company, High Target Company, are dedicated to the research and develop the high precision GNSS positioning technology and also the industry applications. So I want to talk a little bit more about the high precision market in China. China's GNSS high precision positioning market have entered a high speed development as well. And you can see in the next 5 years, China's high precision market will maintain a rapid growth rate of about 48%. 48%. That is too much, right? I was talking about high precision. Here is I mainly talk about the accuracy is down to centimeter level, which means high accuracy, high precision market, okay? And also the high precision technology penetration between China and the world. Right now, in China, is only 9%, but worldwide already 33%, which means in China, especially for the high precision market, GNSS market, have huge potential, and it will keep growing in the next many years. So here we entered the third part, which is about the high precision GNSS industry applications. Here today, I mainly talk about the high precision GNSS industries. Like for surveying and mapping, it requires a centimeter level accuracy. For the safety monitoring, it may remain or require millimeter accuracy. And also the personnel protection monitoring, digital construction, and autonomous driving. Surveying and mapping is a very traditional topics or major that in the world. So the surveying and mapping, I think shortly, it is to mapping the surface or the bottom of the Earth, is to digitize the Earth to create a digital world, which is similar as the Earth, right? In the coming years, there are some new words are very popular, like digital twin, or some other like BIM, BEAM, or SIM. But all those are based on the high accuracy, the maps or the surveying and mapping result. In this purpose, we can see the surveying and mapping is to create like the digital worlds, not only on the Earth, but also flying in the air, in the sky, and also down to the ocean, deep in the water. So here I show a video how the GNSS technology can be applied to surveying and mapping the world. Okay, this is just a very little example, which is showing high precision GNSS receivers, which also have a camera that it can measuring the high accuracy point in the ground, and also taking the picture of the objects, the buildings, or some other objects, or some even surfaces. So then we can use that data to create a DOM or a DLG or some other 3D model, right? Another applications that I need to mention is the safety monitoring, because nowadays the safety is the key. Before we put more efforts to develop the economy, the GDP have been grown so fast, but the safety issues are occurred very frequently. It caused a lot of damages, lost a lot of lives, and also it's very bad result to the society, even to the stable of the society. Nowadays, the safety monitoring purpose based on the GNSS is mainly used for the bridge monitoring, landslide monitoring, dam monitoring, mining monitoring. How can I say? This kind of area, they are open air. It can attract the satellite signals, and it requires a real-time movement of the object. Here shows an example of the system composition of the safety monitoring. Not only a GPS or GNSS receiver, it also combine a lot of other sensors. Like for them, we have radios, we have bubble water level. We need to measure the level, water level. We also have the osmometer to measure the very inner movement inside the dam. And then the data are real-time measured, also broadcasting to the service center. And the service center have one like desktop or Windows, which is can open the data to a mobile terminal like in your phone, and also can be shown in the big screen. So that is the briefly system composition of a monitoring system. Monitoring system right now in China and also in the world are very, I mean, the industry are growing in a very high speed. Like 2 years ago, the government promote one monitoring project, which is to monitoring the landslide, because earthquakes and also flood will cause a lot of landslide. People are living near the mountains. Also in this year, we can see a lot of, actually many cases that this kind of monitoring system have already successfully alarmed the damage or the danger. It also protect the people's lives. There are many news if you check on the TV. Monitoring, like the dam monitoring, bridge monitoring, landslide monitoring, even for many others. Here shows a video, which is the structure, but sorry, this is in Chinese. I will try to explain after the video shows. And you can see, we first build a 3D model of the field site. The monitoring reference points are built on the site. It can be used for the landslide monitoring. This is landslide. For dam, even for mining places. These mining places. Bridge monitoring, which is in Guangzhou, in the south part of China. Also bridge and dam. Okay. The third part of the application I want to share is the personal protection and monitoring. To protect the personal security is the key. First of all, I want to share some numbers that, do you know how many people were killed in the railway in China for 1 year? When my colleagues first tell me, I was wondering like 100, 200. But the real numbers still right now, even in 2020, 21. The real numbers that the people, the total amount of the people was killed in the railway stations is much more than 100,000. It's several thousand person. It's between 2,000 to 3,000 people was killed every year in the railway. And also in many other special regions, like this substation area, because the voltage is very high, it's very dangerous. The workers, they don't understand, or they don't know which area are really dangerous. So in order to solve this problem, we integrate the GNSS high precision GNSS receiver together with the indoor positioning technology, UWB. We put those positioning technology on the head, so it can real time check the movement of the workers. We can also set a limitation area or dangerous area that the workers cannot enter in. When he's entering, the head will automatically alarming, telling that this area is dangerous. When they wearing this kind of equipment on the railway, the system can automatically track the movement of the train. When the train comes, it will also send an alarm to the workers that, please, right now you cannot work in this place, you get away from the train. And this kind of technology has been widely used in China to protect the personal safety and to monitor their movement. Here also I have a video showing this kind of application.
应对各类超范围作业、滞留作业，提前借助天窗作业进行预警，结合来车信息，可向现场作业人员进行提醒及防护。同时，在机车顶部
positioning technology also can be integrated on the tablet or in a phone.
位置及发车进步位移、视频、气象及异物入侵传感器，提前掌握线路安全信息。
There's another GNSS receiver installed on the train. So the workers can know the train is coming. And also the driver of the train knows if there is any workers on the train, along the railway. For example, we believe that the technology, the value of the technology is to protect the people, to create a value to the society. Then let's keep talking about the digital constructions. Construction is a huge market and it have a lot of requirements from the market. I mean, especially in China and many other developing countries, the government encouraging the infrastructure construction to encourage the economic growth. But for the big machine or in a very big area, working area, how can you ensure the accuracy of the construction? How can you ensure the safety? And how can you ensure the efficiency? By installing the GNSS, high accuracy GNSS on the tractor, on the machine, or excavator, it can guide us the machines to work. Even together with, even based on the high accuracy background maps, it can automatically to do the construction works. We call it non-people construction. Non-people. This gonna be in the future, but definitely it will gonna be happen in the coming future soon. like for the compaction system, from the pile drive construction management, for the prototyping and leveling construction, even for the excavator 3D guidance. Here also have a video.
海达 PDS 100北斗装机智能引导系统，采用北斗高精度定位技术，融合物联网、云计算技术，实现厘米级打桩定位。安装在装机上的 GNSS 天线，通过接收卫星及基准站信号，进行零和结算，实现精准定位。机长根据舱内的终端频繁指示，快速锁定装点位置，操作简单。 无需人工放样，通过智能引导施工。
Okay. Even this is a very little examples showing the video about how the GNSS is guiding the big machines to work. But combine a screen and the software, it will automatically guidance the big machine to work. So the purpose, of course, is to solving the safety problems, to saving the accuracy problems, and also to improve accuracy for the working site. And then autonomous driving. The autonomous driving is very popular and it's very hot, in a very hot level all over the world. But still, even Tesla, they cannot say they are fully autonomous driving because right now there are two kind of autonomous driving solutions. For Tesla from the US, they are using a pure camera because the Tesla, they believe driving a car, machine driving a car must be like human driving a car. So what is the sensor for the human being to drive the car? Of course, eyes. So they insist to use a camera and also the big computer machines on the car to solving the autonomous driving problems. But there's of course another solution which is more widely used for the autonomous driving. They are based on the high precision maps. They're using the real-time positioning technology and also the IMU to capture or to measure the real-time speed, directions. Also combined with the camera, the vision. So here I'm talking about the second or the most popular ways or solutions rather than Tesla. They must be based on the GNSS technology. They need a high precision real-time positioning. Even not only showing the real-time position in the open air, but when we're driving in the city across many buildings or even down in the into the ground, no signals. So we have to combine with the IMU together with the GNSS to solving the problem that when the GNSS lost signals, there's still processing the data using the IMU to give a high accuracy positioning, direction, and speed data to ensure the autonomous driving. I also have a video showing how the autonomous driving is worked based on the GNSS.
高精度定位是实现自动驾驶车路协同的核心基础。中海达 IPMV 高精度多元数据融合导航系统，包括自主研发的组合定位导航模块、车载高精度定位天线，同时配备中海达核心定位算法，搭载在汽车内的 IPMV 导航系统，融合卫星导航、惯性导航、室内定位。 高精度地图、视觉传感，利用卫星与车辆通讯获取可靠的绝对位置和航向信息，在高速、城市、隧道、地下车库等复杂场景轻松实现自动驾驶。 确保安全性的同时 ，GNSS 定位精度达到厘米级。为乘用车自动驾驶、商用车编队驾驶、干线物流配送小车、智能巡检机器塔、智慧交通车联网、CV2X 十字路口等终端使用场景进行赋能。
I speak a little more about the autonomous driving. The electric car, they install a high accuracy GNSS antenna, and also it have a processing unit inside the car. So it is receiving the like 1 centimeter or 2 centimeter accuracy data in real time. And then the car knows exactly where it is, but knowing where it is not enough. The autonomous driving car must base on the high accuracy maps. It's different. It's different than the normal Google Maps or commercial maps like Baidu Maps or Gaode Maps. The high precision maps are accuracy the less than 5 centimeter. So on the high accuracy maps, having a real-time high accuracy position, it ensures the real-time accuracy positioning for the car. Now, electric cars are very popular. If you go China, I think many of you guys may already been to China. But in China, we have many electric car companies right now. They are producing the best electric cars, even better than Toyota, Honda, Volkswagen. The electric car like Xiaopeng. Xiaopeng are based in Guangzhou, which is the city as my company. Another company was NIO, Weilai, and also Li Xiao. Those companies would be also providing their autonomous driving cars globally soon in the world. And not only about what I have told, the autonomous driving, personal protection, safety monitoring for the dam, landslide, buildings, bridges, and even a surveillance mapping. Still, the high accuracy GNSS technology have been applied in many other areas, like the telecom communications, 5G together. In China, we have 3 telecom companies. They are building like several 100,000 base stations for the 5G in the whole China. And also, those companies start to build the GNSS reference stations all the world, all around the world, and also especially also in China. Like there's a company called 中国移动, China Mobile. They built 4,400 reference stations in China. The purpose for them is to aiming at the future IoT industry. They are not only provide the 5G telecom data services to the users. In the future, if you buy a phone installing a SIM card, you can select the services like data. Even you can just one button to switch on the high accuracy services. This is a trend in China. I believe this is happening all over the world. The big telecom companies, they are building the reference stations. They are providing the data services, and as well, they are providing high accuracy correction data services, positioning services to the users. This is the trend. And also for precision agriculture, 10 years ago, I was traveling to Europe and to the US. I was saying the tractor is automatically seeding or harvesting to collecting the seed automatically, very smoothly and very smart. But until now, after 10 years development in China, many big farms in China, we already have the precision agriculture machines the agricultural machines are doing their jobs automatically in China now. And of course, the aviation. In the past 3 or 4 years, we can remember there are several very serious aviation disaster happened. Even in this year, there's one happened in China, which is in Guangxi province. They are trying to find the data trackers to find out where the plane it is. But this question or this problem are very simple to us, you know, because still until now, the plane do not have a real-time data, real-time high accuracy GNSS data recorder to broadcasting the data of the position to the monitoring center. They are just using the radar, and also they have a recording box inside the plane. But we believe that the GNSS real-time, high accuracy real-time recording and also sharing the data to the monitoring center will be applied in the future, because the technology already very it's a very stable function. It's not very difficult, but to proceed to change the protocols or the principles for the aviation is very long term. So that is the reason why still for the aviation part, they are not still using a real-time GNSS recorder. Of course, we can imagine how many possibilities for the future or in your local countries that the high accuracy GNSS technology can be applied in the different countries, in the different regions. Okay, today, all those are about, I have already talked about the GNSS technology development, the GNSS market, especially the high precision GNSS market. And also I spent a lot of time, the most of the time talking about the applications. Which industry using the GNSS can solve the problems or to improve their accuracy, to improve their efficiency, to ensure the safety. So the last part is about a little bit about my company. HiTarget is a public listed company which is listed in the Shenzhen in China, and the code is 3000177. We are a geospatial technology developing technology companies which doing the research about the GNSS and also the geoinformation technologies. Our product and solutions covered the land, the oceans, even the UAV airborne.